All right, it's time for the big script, the player, the one that's doing most of the work in our game. Let's open up the player script and start at the top. So up at the top, we've got these using statements, and I've mentioned them a couple times. We've kind of ignored them, but I want to briefly talk about what they are. These statements allow your code, all of the code below them, to use specific libraries or systems. They allow your code to use things that it might need to use that you wouldn't want to have to write yourself. Things like lists of objects or random number generators or Unity components, which is why we have the Unity engine one here. If we didn't have this using Unity engine statement here, if I just deleted it, the mono behavior reference is going to disappear, serialized field, sprite, layer mask, all of these things, the game is no longer going to know about them because they're all in that library. They're all in the Unity engine library. So I'm going to undo that, bring that using statement back in, and make sure that my code knows about all of these things. Now you might see these two gray ones here and wonder why are they light gray. That's because these ones just aren't being used right now. So I can actually delete them just by holding shift and hitting delete and shift delete and removing them. The reason that they were there though is that those are very common ones that are often used in game development and writing code. So it just puts them there kind of by default. We can remove them though because we're not using them right now. So let's get rid of them. Let's take a look at the next line. We've got line 4, our public class player. Inherits from mono behavior. I think we've talked a little bit about that. Probably don't need to talk more about it. And then we've got a private float jump end time. Now, one thing I'm noticing is that this float is surrounded or kind of like followed by some serialized fields, and then there's more floats and other private variables down here. So I'm inclined right now to just move this line down here to line 21. So I'm going to hit shift delete and move it down to line 21 so that it kind of lines up and is in line with my other jump private fields. Then I'll delete line 6 here. I like to keep my code nice and clean and organized so that it's easier for me to find things. So now on line 6, I have a starting block of serialized fields. And remember, this attribute here with the square braces makes it so that our variable will show up in the inspector. If I save, go over to the inspector, I should see horizontal velocity, jump duration, jump sprite, layer mask, and foot offset, all in that order on my player. Let's go double check, make sure that I'm not crazy, and we're seeing the same things. So we go look at our player, we expand out the player script, and there we go. We've got all of those fields in the same order, and we have is grounded. So let's go back to our code. Down here, we've got that is grounded right afterwards. And remember that this is public, which also shows up as or in the inspector, just like the serialized field. Now, the reason that this is public, well, we haven't talked about that yet. We're not going to talk about it right now. We'll talk about public and private stuff a little bit later. But for now, we're going to continue on and just know that when we have something that's public, it can be accessed by other code outside of the player. And when we have something that's private, it cannot be accessed by other code outside of the class. And that matters. Well, it matters for this because some things are going to want to know if the player is grounded, but nothing else should need to know about our foot offset or our jump duration or our jump sprite or anything else. Some objects might need to know if we're on the ground, though. So we make that publicly available. All right, next up we have our private fields. Starting on line 15, we've got a sprite renderer that we're caching in our awake. We've got an audio source that we're caching in our awake. And we've got an animator that we're caching in our awake. I'd like to keep all three of these components in the same kind of order or next to each other. So I'm going to move this animator right up here and then delete out line 19 just to keep them kind of in order. And in fact, since they're components, I'm even going to add a space to separate them. This is something I highly recommend you do with your code. Keep it clean, keep it organized, and just go through, and when you just need a break from thinking too much, just start cleaning up your code. Just reorganize things. Just make sure that it works and that you've got source control. So if you accidentally delete the wrong thing, you can go back and undo it and fix your problem. All right, so we've got our three components that we cache in our awake, and then we've got our horizontal value for where we're pushing left and right, our jumps remaining, and our jump end time. So this is when our jump is going to end and how many jumps we have left. We've already talked about awake enough that I don't think we need to explain what caching looks like or what we're doing there. So we're going to minimize that and look at the gizmos. Remember, gizmos only show up if you have that little world popped on, and they don't interact with the world at all. They're just for the scene view. And in our onDraw gizmos, we do a couple of things. First, we get the sprite renderer. And I guess it's kind of important to note that we can't just use the sprite renderer from Awake, because Awake isn't necessarily called every time when onDraw gizmos is. If we are not running, we're just in the editor, Awake's not going to be called. So we need to actually get the sprite renderer. Then we set the color of our gizmos to whatever color we want to draw in. Whatever color is set is the color that the next gizmos draw line will be in, or gizmos draw anything. Then we've got our origin right below that on line 35. We declare an origin, and we use our current position minus our bottom, or our extents of our bottom there. So we get the position right at the bottom in the center, and we draw a little line from our origin downwards 0.1 meters. We do the same for the left and the right foot just by subtracting and adding the foot offset. Then we've got our update method. Remember, this is where all of the magic kind of happens. This is the core of our game logic right now. We've got an update grounding method that updates whether or not we're on the ground. If we look at it, it has the is grounded value getting set to false. And then we do a raycast downward, just like we did with the gizmos, but we're doing a raycast instead, where we get back a raycast hit. If we hit something, anything at all right now, then we set is grounded to true. Otherwise, we just leave is grounded to false. So first we check in the center, then we check in the left by just doing that same raycast, and then we check on the right. Now, theoretically, if we've hit once, we probably don't need to check all the other ones. If we hit in the center, we don't need to check the left and the right. It's somewhat inefficient, but for now, we're not worrying about speeding that up and optimizing it. It is something that we'll be addressing soon, though. And then on line 97, we just check to see if we are grounded and we're not flying upwards, then yes, if our velocity is less than or equal to 0, so we're either at 0 or falling downwards, so not flying upwards, then we set our jumps remaining to 2 so that we can jump again. Now let's go back up to our update, and the next thing that we do is read our horizontal input. And again, we're using the old input system, but we're very soon going to switch to the new input system, and it's going to look a little bit different. So we've got the old input system using get input, or input.getAxis horizontal, which gives us the left and right value, which is the arrow keys A and D, or remember it also is the thumb pad or the thumbstick here, the left thumbstick on a normal controller. So it gives us a value of -1 to +1, depending on if we're pushing all the way to the left or all the way to the right. We log that value out, which we probably don't need to keep doing, really. It's kind of obnoxious. So I'm going to delete that line right here, line 53. And then we'll go down to line 54, where we get the rigid body component. And then we set we get the current Y velocity of our rigid body and set that in vertical. But don't we already cache the rigid body up in our Awake? Let's go take a look. So we don't cache our rigid body in Awake, and that's something that we should probably do as well. So we're going to make that change now. We're actually going to go up to the top, and we'll replace this code here and say underscore rigid body. Actually, let's do RB, since that's what we've done before. Underscore RB equals get component, and we'll put in a rigid body, but we don't want a rigid body. We want a rigid body 2D. Very important that we get the 2D one. I'm going to generate a field for it, and then we'll add another space. We'll get rid of that private keyword, and then we'll scroll down. So now we've got a cached rigid body, and we'll delete line 56 and add an underscore to our vertical. Look at that. I already feel better about our code. You'll see down here on line 72, we've got an error. We'll talk about that in a moment, or we'll fix it in just a moment. So we get our vertical velocity from the rigid body, our current vertical. So if we're going up, we know that value. If we're falling down, we know what that value is. And then we check to see if the player has pressed the fire 1 button, because we're using that to jump. That's our left click or left control. And they have some jumps remaining, more than 0. So if the value is greater than 0 and they've pressed the jump button. And remember, get button down in the old input system is the frame when they've pushed the button. So it's not if they're holding the button, but if they push the button, this frame. Then we set their jump end time to the current time plus the duration of a jump. So if it's 1 second jump, then we would set it to the current time plus 1 second. So that way we know, hey, at 2 seconds in the game, if we did this at 1 second, we add another second at 2 seconds in, their jump needs to end. And we'll use that later on in our code, remember. Then we decrement their jumps remaining by using the minus, which just removes 1 or reduces it by 1. We set the pitch of our audio source so we can get that cool effect based on how many jumps we have. And here we're using that conditional operator. So if jumps remaining is greater than 0, we set the pitch to 1. If it's less than 0, so it's not greater than 0 or equal to 0, then we set it to 1.2. And then we make the audio source play. We could probably delete that space on line 64. I'm going to do that. Line 67, we check to see if they're still holding down the fire button. Remember, this is the frame that they clicked it. This is the button, every frame that they're holding it down. Get button will return true. And it's still an okay time. And we determine it's an okay time by saying that the end time is sometime greater than the current time. So if we haven't gotten to the end time, they're still holding the button down, we let them keep going up. So we keep setting their vertical value to jump velocity. And imagine that their vertical value is like a +3, so they're going up 3 meters per second. As long as they're holding the button, they're going up 3 meters per second. Otherwise, they're going to start falling down based on the rigid body. It's going to start pulling it down with gravity and falling on its own. So it'll be 3, then it'll be like 2.9, 2.8, 2.7, and so on, until it starts to get to negative values and falling down. Then on line 71, where we've got our error, we set the velocity of the rigid body to our newly calculated value. Let's add an underscore there. Oh, and talk about line 70, where we multiply our left and right speed by our horizontal velocity value. And remember, that was a serialized field. Controls essentially how fast we run. I'm going to go back and then take a look at the last bit of code here. Line 72, we call update sprite. If I hit F12, you see that it actually updates our animator and our sprite. So it probably needs a rename, but we're not going to do that yet. The animator gets a Boolean set for whether or not it's grounded to modify its jump sprite mode, so whether or not it shows a jump sprite. And then it gets a float for its horizontal speed, which passes in that absolute value of the horizontal speed, which is just that value without the minus sign. Then if they're going to the right, we set flip X to false so that the sprite's not flipped and it's at the normal mode. And if they're going to the left, we set flip X to true so that it flips over. And if they're not going anywhere, they're not pushing left or right, then we don't flip it so they stay whatever direction they were facing. That is the entirety of our player script. So hopefully we now understand everything that's in here, because we've got a lot more code to write, a lot more really cool stuff to do, and things are going to get a lot more, I think, interesting and fun. All right, let's save this off. We'll go back into Unity, into the plastic SCM window. We should have a couple of changes here to commit. So I want to get this window open. We'll do a diff now, since we've been doing those. We'll right click on this player and hit diff so we can see our changes before we commit them. The minor modifications we've added, we moved the jump time down so that it was in a better space. We removed some unused using statements. So this is showing us that those were removed. They used to be there, now they're not. It's showing us that our animator kind of got moved around. It got deleted and then re-added down here. And let's see, our rigid body component is now being cached. If we scroll down further, we'll see that we're using the cached rigid body in both of those places, and that's pretty much all of our changes. So I'm going to close this window. We'll go add in a commit message that we cleaned up the player class a little, and we'll check that in.